Light. So essential, isn't it? Without it, you can't see anything. It can be an issue for reading or watching things, eating, and even moving around. You keep bumping into things. So, let there be light. So, what is light? It is a form of energy, a part of which we can see. How does that work? Light energy is created, energy can't really be created, but it is formed from electric energy like in a light bulb, or from burning things like in the sun or a candle flame back here on earth. So when this light is created, it travels outwards in all directions in the form of radiation. If you observe carefully, all these light rays are traveling only in a straight line. Not convinced? Just switch on a torch in the night. Light always travels in straight lines. It's kind of why we have day and night, isn't it? So if light could bend, it would just bend around the earth and light up the night sky. It's why we can have shadows also. Anyway, this property of light is called rectilinear propagation of light. That is, light travels only in straight lines. One of the options in that question brought up a valid point. If light travels only in straight lines, shouldn't that mean that it should be dark here if there was a shelter or a shade above you? Sure, it is a little dark, but we can still see things, right? Now, how does that work? Well, light cannot bend on its own, but we can change its direction. All we have to do is put a thing in its path. When light travels, suddenly there's a barrier, some light is absorbed by the thing, and the remaining is bounced off it. We see the thing when this bounced off light enters our eye. Normally, most things are rough if you see them from really close. See these hills and valleys? So when light falls on them, different rays are bounced off in different directions. That's how we can see many things from many different angles. Now consider a smooth surface like glass. Smooth surfaces don't have as many hills and valleys. It's pretty uniform. So when light falls on such a surface, it is bounced back pretty uniformly too. This kind of bouncing back of light is called reflection, and it happens on any surface as long as it's smooth enough. Mirrors are the best example and make the most of this reflection stuff. Because of this uniform reflection, you can see your image as it is and not weirdly distorted. We use this in so many different ways. So, normally we say reflection of light is the change of its direction by a smooth surface like a mirror. So, when you stand in front of a mirror, light rays from you go straight towards the mirror and get reflected off the surface. Now, since this is the same light that comes from you, you can see an image of yourself in the mirror. But if you move 2 steps to the left, you don't see what was behind you anymore. You see the stuff that's further on the right. So that is because light from that thing hit the mirror at a particular angle, which then entered your eye after reflection. So this particular angle at which it hits is fixed and depends on how the light rays hit the mirror in the first place. So there's some geometry involved with this whole thing of how reflection takes place. You see, reflection of light always follows a couple of laws which are never ever broken no matter what. Consider this laser pointed at this mirror. This beam hits the mirror like this, and this is the reflected ray. Freeze. So this ray going towards the mirror is called the incident ray because it is incident on the mirror, and this ray going away is called the reflected ray. Pretty obvious? Now look, we're dealing with rays and angles here, so there is some geometry involved with reflection. So consider a perpendicular to the mirror at exactly this point where reflection is happening. This line is called the normal. So what is so abnormal with the rest of the things, or what is so normal with this? I don't know. That's just a name given to perpendicular things. Must have to do something with the meaning in Latin. But this angle that the incident ray makes with the normal is the angle of incidence, and the reflected ray makes the angle of reflection. So, the laws of reflection. According to the first law, the incident ray, the reflected ray, and the normal all lie on the same plane. What this means is that if I point the light ray like this, horizontally, the reflected ray is also going to be horizontal and on the same plane. And if I make it vertical like this, then look, reflected ray is also vertical. It can never happen that the incident ray is from the bottom and the reflected ray goes somewhere else to the side. The second law of reflection deals with the angles made by these rays with the normal. It dictates exactly where the reflected ray goes. It states that the angle of incidence is always equal to the angle of reflection. This is the reason you see only certain things always at a certain position from the mirror. This is the reason your image in the mirror also moves as you move. Because the angles of incidence from you are changing, the angles of reflection are also changing. These two laws are very, very important for light, and they have never been broken and they never will be. But to know at least some laws are upheld in this world. So when you look at yourself or anything in the mirror, what do you notice? Your image is standing the same way as you are, that the image is erect, it's not upside down. Also, your image looks like it's behind the mirror on the other side, but you can't really see it or capture it by looking behind the mirror. That is because it doesn't really exist. It is a virtual image. It is only a perception. See, we're used to seeing light travel only in straight lines, so our eyes cannot trace the exact path of the reflected rays and think that they're coming from somewhere behind the mirror. So we see this thing as being inside the mirror, even though we somehow know it's not. Since the mirror is straight and the reflection is pretty straightforward, the size of the image also stays exactly the same size as the object size. But something interesting happens to a mirror image. If I lift my left hand, it looks like my image lifts up its right hand. This phenomenon where left appears as right and right appears as left is called lateral inversion. It's the reason why words appear so weird in an image. Now you know why ambulance is written like that on the actual ambulance. When you're driving and it comes up behind you, the word gets inverted in the rearview mirror and the driver can read it and move it to let it pass. There are some letters though that don't appear all inverted in a mirror. Guess why? Have you wondered why lateral inversion happens though? Like why sideways and not upside down? Well, think about it and share your ideas in the classroom. In the meantime, did you know that in some mirrors you aren't exactly the same side or even the same side up? How is this magic possible? Find out in the next segment.